When you start your first Godot project, it's probably just a single screen. Then that screen turns into a room, that room turns into a level, and then suddenly, where does the main menu go? What about the HUD?
How does the HUD know
Should
about
the level create the player? Who handles the pausing? How do scenes change? One of the most important things you can do for your project is set up a solid foundation before it starts growing in every direction. I spent a decade programming software for the aerospace industry, and now I make games. I don't claim to know everything, but I have learned the hard way what happens when you code first and plan later. This video is the start of a series where we build towards a full vertical slice of a game, covering the vital setup steps, major systems, reusable components, and most importantly, the thought process behind each design decision. By the end, we'll have more than a working demo. We'll understand how it works, why it works, and have the confidence to continue growing the game from there. This is the prototype of the general theme I'd like to aim for. Top-down pixel art with lighting, subtle shaders, and eventually a UI, pause menu, debug menu, and actual gameplay systems. But if the project underneath this is just one level scene with everything shoved inside, then every new feature makes the whole thing harder to change. So in this video, we're going through the setup steps and building the structure underneath it, a foundation that can support the entire game. First up is probably the most impactful decision that needs to be made. And I'm hoping you all can help me with this one. We need to decide what kind of game we're going to make. I know, real groundbreaking stuff, but we should really know at the start if we're building an online PvP, EVP, MMO with crafting and looting, a top-down RPG, or a side-scroller. All joking aside, this does change how we reason about the project. So let me know in the comments what direction you'd like to see this game go in. A more traditional RPG or something more action-based? It's all up to you guys, but within reason, we're not doing an MMO, okay? Let's not get crazy. So where were we? I've also opened up a Discord for anyone following the series or just interested in discussing Godot architecture. Check out the link below if you'd like to join. The next important step is to determine an art style. For this series, I'm aiming for a top-down pixel art game with some modern touches. Lighting, glow, shaders, smooth camera movement, and eventually a higher resolution UI. That visual style affects some vital project settings, and pixel scaling is absolutely its own rabbit hole, which unfortunately will turn this entire video into a camera and rendering deep dive. That will come soon, but the important point for now is this. For this project, we're using canvas item stretch mode. That allows us to build around the pixel art base resolution while still allowing for modern effects and smooth camera. The other common option is viewport, which renders the whole game at a low resolution first and then scales the final image up. This is perfect for true retro style, but it also forces those modern effects to inherit the low resolution as well. Now that we know what we're making, the next decision is where everything should live. Unfortunately, there's no perfect one-size-fits-all folder structure that works for every Godot project. A quick search for best Godot folder structure will give you a different result on every page. And many people have strong feelings about this, so I'm not going to pretend that this is a singular, perfect way to organize a project. But I think most people agree that the name should be clear, descriptive, and consistent. Whenever I create a file, I should know where it goes without having to stop to think about it. If I'm making a scene, I shouldn't be asking myself, does this belong in components? Or is it an effect? Oh, it's part of a level, should it go in there? Or is it a tool? It's hard to look back on old projects. It's fine, it doesn't bother me, it doesn't bother me. It bothers me a lot. Alright, so the first project doesn't have to be perfect. But let's go over the folder structure I use now. To start, I prefer to separate raw assets from source. So I create an assets folder for the raw art, textures, and audio. Then I create a source folder for the actual game scripts, scenes, and resources. Inside of source, I separate things like core for the main game scene, auto loads, and high-level systems, data for resources and definitions, gameplay for the player, enemies, NPC, components, and mechanics, levels for levels, scenery, and level-specific objects, shaders, because it's nice to keep those easy to find, UI for HUDs, menus, and pause sections, and debug for anything strictly used for debugging that should not accidentally become part of the final game. This exact setup is not sacrosanct. The important part is to have a clear mental map that works for you and makes sense to anyone joining the project later. But folders only solve where the files go. The bigger problem is deciding what those files are actually responsible for. So before we start building the main game scene, we need to decide what each major scene owns. When a project gets messy, it usually doesn't happen all at once. The technical debt creeps in as the project grows, especially if ownership is never clear. The main game scene, level scenes, player, HUD, and pause menu all own certain things, and they need to communicate within and outside of their own scenes. If we don't decide those ownership boundaries early, every scene slowly starts talking to every other scene, and then it becomes obvious why it's called spaghetti code. So here's the basic structure I like to use. The main game scene is the application root. It is a scene we set as the main scene that loads when the project runs. It creates and owns the major layer structure. It provides roots for the world, HUD, pause menu, transitions, and debug overlays. It initializes high-level systems and coordinates scene transitions. The important distinction is that main game is a coordinator. It coordinates the big pieces without micromanaging the entire game. That boundary is what keeps it from slowly turning into a God object. The level scene owns level local objects. That includes the geometry, tile map layers, backgrounds, environment settings, spawn points, enemy placement, and any other data that belongs to that specific level. Notably, in this setup, the level does not own the player scene. Instead, it exposes markers where the player can spawn. That helps decouple the level from all the baggage that comes with creating the player. The level doesn't need to know which player scene to instantiate, how to connect that player to the camera, or how the HUD gets updated. The level just needs to be a level. This does create a bit of an issue when it comes to testing, but having to deal with that is a better solution than making every level have to boot basically in the entire game. So let's put a pin in that. That's going to require a full video, which will be coming soon. We have everything we need to set up the main game node structure. Now that we know what everything is supposed to do, it's time to put the scene together. The design philosophy here is simple. Main game provides stable containers. Those containers act as root points where the correct scenes can be loaded. First, I have a systems node. We haven't implemented the high-level systems yet, so right now this is mostly a placeholder. But having a defined place for the systems early means we are not scattering managers randomly across the tree later. Next is the world, which is a node 2D containing the actual in-game world. This should move with the camera, use world coordinates, and contain the level, gameplay objects, and effects. Inside the world, I separate things into roots. The current level gets loaded into the level root. Players, enemies, NPCs, pickups, and other active objects go into the entity root. And temporary visual effects can live in the effect root. When I first separated entities into their own root, I was not sure if I would like it, but it actually makes a huge difference compared to spawning everything deep inside the level. When running in debug, I can clearly see every active entity currently in the scene tree, instead of digging through several layers of level sections. The remaining layers are UI nodes under separate canvas layers. This keeps them separate from the world transform and allows us to define which layer is drawn above the others. The world is effectively at layer 0, the HUD is above the world, pause is above the HUD, transition covers the normal game layers, and debug goes on top of that. I like leaving gaps between the layer values because there's always a chance I'm going to have to squeeze something in later. So, now we have a scene tree that looks organized, but there is a potential trap here. A clean tree does not automatically mean the game behaves correctly when paused, loading, or transitioning. Speaking of pausing, before we move on, I have one quick channel update. Memberships are now open. Members get early access to videos along with member-only posts and polls where you can help shape future content. I may also occasionally do some bonus videos or member-only streams. Speaking of, I'm also planning to start streaming soon, so keep an eye out for that. Membership directly supports the channel and helps me spend more time making these videos and hopefully get them out a little faster. If you'd like to support the channel and get a little more involved, you can click join below to see the membership options. Alright, now let's get back to scene tree pausing. In Godot, every node has a process mode that controls whether it runs when the scene tree is paused. By default, nodes inherit their process modes, so if the option is never touched, pausing the scene tree can pause basically everything. This was something that gave me some trouble when designing room transitions in my first project. The whole scene needed to pause during the transition, but some processing still had to continue in order to move the camera and, even more importantly, to unpause. So for this project, we want to set the process modes intentionally. Main game should, of course, always be running. The world should be pausable. The HUD can be pausable for now, though that might change later. The pause layer better be able to process when paused. Transition should always process, and debug should always process. The exact settings are not carved into stone, and may change later based on what we end up doing with the layers, but it's something we don't want to forget about while we're developing the game. If we have an elaborate animated pause menu, we don't want to be taking away processing resources from the game while it's not being shown. More importantly, we do not want to halt important processing due to pausing the scene tree. And at this point, we have our foundation set up in the editor. Time to set up the script to actually use it. We're going to keep the main game script relatively simple because the game currently only has a test level and a player. It doesn't need to be fancy on day one. As the game grows, most of this logic may move into systems or managers, but keeping it in the script works as a baseline. I'll start by dragging in the scenes for the player in the test level, but all I want is a UID string, so I'll remove this preload here. Then I want to grab references to our root nodes as onReady variables. This can be done in the editor by dragging them, and holding Control will automatically format them. I'm adding the UI root nodes as well, but today we're only going to focus on the player and the level. So let's start off with the player. We'll add a function called the ready function to initialize the player. The function itself loads the packed scene resource, instantiates the scene into the player variable, then adds it as a child of the entity root. We perform these same safety checks here in the load level function, so I'll explain those more in detail in a little bit. Note that since MainGame is our coordinator, it creates and adds the player, but it does not control any of the player's behavior. That will happen in the player scene. Next, we create a load level function. This becomes the stable place where level changes are requested. If the main menu starts the game, it calls load level. If the player walks into a cave and changes zones, that also calls load level. The implementation is simple right now, but the caller doesn't need to care. Later, this function can grow into fades, loading screens, threaded loading, or whatever transition system we need, without changing every scene that uses it. For the current version, the flow is simple. We defer the level change so it happens during the idle frame. If there's already a level loaded, we call queueFree. Then we allow the frame to process so the old level can clean up. After that, we load the new scene, instantiate it as a base level, and add it to the level root. By casting it as base level, we get a simple safety check. If the scene is not actually a level, the current level stays null, and we know something is wrong. We performed the same check on the player earlier. The last piece is to place the player at the level spawn position and set up the camera. This is where the earlier responsibility split pays off. The level exposes a spawn point, and the main game moves the player there. Then the main game connects the camera. Now the level is loaded, and the player is in it. It's not complicated yet, and that's the point. The goal today is not to build the final loading system. The goal is to create one stable entry point that future loading systems can go through. At this point, we've done a lot of foundation work. And to be honest, I may have overscoped myself a bit and written a much longer version of this video than intended. So I had to cut a few of the rabbit holes out of this one. Pixel scaling, camera movement, tile map layers, and auto tiles, debug tools, and project automation all deserve their own dedicated videos. The good news is that now that this foundation is in place, and a lot of those scripts are already written, those videos should move much faster. So keep an eye out for the next one, along with some streams starting real soon. I have a project plan that I'm really excited to build with you all. Members get early access to videos, and the Discord link is in the description if you'd like to join the community. I have a Ko-Fi link to the description as well. No pressure. Watching, commenting, and subscribing is already a huge help. But either way, I'm really excited about what's coming next. Thank you all for watching, and I'll catch you in the next one.